Hi everyone, this is Mrs. Torigno, and this is the last problem from the first review packet for the Algebra 1B semester exam review. This video will just focus on problem number 35, which was the scatterplot problem. And it's asking us to make a scatter plot of some data that has to do with life expectancy based on the year. The first thing it's asking you to do is actually draw the scatter plot. Now the scatter plot has to be drawn by hand. The scatter plot that a graphing calculator gives you doesn't really help you much because it doesn't give you an accurate picture of how the axes are numbered. So really you just have to suck it up and do it by hand here. Notice that I already have this one done. I did this ahead of time. And I'd like you to pay attention to the fact that the bottom axis, the x-axis, is your years, and along the left side, that's your life expectancy. Probably label that for you. This is years, and over here is the life expectancy in that year. But I didn't just take the numbers out of the table and list them on the graph. Okay, notice here I counted by 10 years, so every line represents 10 years, and up along the side I'm counting by 2s to represent how many years your life expectancy is. I see a lot of students trying to just list the problems that are actually in the table. Remember, when you're doing a graph, you have to count by even increments every time. So just be careful with that you don't want to just take the numbers out of your table and list them in your graph. You have to count by an even increment. Now, it doesn't have to be the same increment for the x-axis and the y-axis. Like, for example, here I've counted by 10s and here I've counted by 2s. That's okay, but I can't just list the numbers that I want to see in my graph. Okay? Then I went through and I just put a point for each one of these data points. So for example, in 1950, I estimated where 68.2 would be along the y-axis and put a point there. I'm going to jump down to 1989. I had to estimate where 1989 would be right before 1990, and then I also estimated the data point 75.1. So there will be some estimation here. Not every point is going to lie right on the intersections of the graph boxes. Okay, so this is what your scatter plot should look like. I also want you to notice that there is no line drawn between these points. You do not want to connect the points on a scatter plot with a line. Okay, later on we'll talk about the line of regression, but even the line of regression doesn't connect the individual points, so no line there. Okay, so there's our scatter plot. I apologize that that left side is a little bit blurry. I smeared my own ink. And now I'm going to move down to parts B and C, where it's asking you to calculate the line of regression. These parts you will need a graphing calculator to do. Okay, so here's mine. I'm going to move it up just a bit so that you can see the buttons that I'm pushing. Looks pretty good. And I'm going to start by finding the stat button. And on the TI-83s and the TI-84, the stat button is just down and to the left of the arrow buttons. So right here is my stat button. The very first option you will see there is edit, and that's what you would like to choose. And you should see two lists, L1 and L2. Now, I already have my data in those lists. Hopefully you can see that. But in L1, I just typed in the years from the table, and in L2, I typed in my life expectancies. Okay. After I have those data points in, I'm going to go back to that stat button, but this time I'm going to move over one to the right to the calc menu, and then option number 4 is line of regression. Now, once you get that on your screen, it's going to look like this, and then you just have to hit enter one more time. You should see all 4 of those things there, A, B, R squared, and R. If you do this on your own calculator and you're not seeing the R squared and the R, just let me know in class. There's a setting I can fix to fix that for you. Okay, when I look at my calculator screen, I see that it says the line of regression is y equals ax plus b. That's this right here. And then just below it, it gives me a value for a and a value for b. That's just telling you to take those a and b numbers and fill them into that form that it gives you at the beginning. So my line of regression from my calculator should be y equals 0.166x. And it is okay to round those decimals. Those decimals will usually come out pretty long, so it's okay to round those. And then minus 255.03. Okay? And that's what you would write for your line of regression. You don't want to just write the numbers down. You actually want to put them in the format of a linear equation. Okay? Part C wants you to find the correlation coefficient. I'm going to go back to my calculator screen here for a minute. And if you'll notice, the very bottom thing given to you on this screen is R. R is your correlation coefficient, and ours is 0.9899, and then it continues from there. So for part C, where it says to find the correlation coefficient, I'm just going to write R equals 0.9899, and it's a 0 after that, so it doesn't round or anything. All right, I would just leave it right there. The next question is the important one, though. It says, does a linear model fit this data? Remember that to figure that out, you want to look back at that correlation coefficient, and the closer that is to 1, the closer this data is to being in a straight line. If you look back at our scatter plot, this is pretty close to being in a straight line, and that's what this correlation coefficient shows us too. This number here is really close to 1, so I would say yes, a linear model does fit this data because our correlation coefficient is so close to 1. Okay. So take just one more second, make sure you can see that scatter plot, make sure you can see how I've numbered those axes, and then parts B and C again come from your graphing calculator. And that's it for your first packet. We're halfway there. Stay tuned for packet 2.